Hi again, guys. I'm going to be going through a problem here where we're going to be solving for the limiting reagent as well as the percent yield in this equation. And if you look in this forum where I posted this video, look at the question before you watch this video so that you can see all the numbers and stuff that I'm going to be using. So the first step for any of these problems is to always convert things to moles. Because once you have everything in moles, you can use the molar ratio between everything in your chemical equation to solve for just about anything that you want. So the first thing we're going to do when solving from the limiting reagent is we're going to look and see how much copper sulfide we can produce given the certain amount of starting amounts of sodium sulfide and copper sulfate that were given in the problem. So the first thing we're going to do is convert the 15 grams of sodium sulfide all the way through to grams of copper sulfide. So we start with 15 grams of sodium sulfide. And I'm using this grid system here to kind of keep all my units in check. Obviously, when you enter everything into Sakai, doing a grid like this is a little bit more difficult. So just put all your conversions and stuff in parentheses. Then they'll be kind of fractions, and I'll be able to follow your work. So we have 15 grams of sodium sulfide. We can convert this to moles of sodium sulfide using the molar mass. So we have, in our units, we have 1 mole of sodium sulfide, and that has a mass of 78.05 grams of sodium sulfide. And I'm going to keep track of the units as we go, just so we can kind of simplify everything. And as you can see here, grams of sodium sulfide are going to cancel in the top and in the bottom. After this particular step, remember we multiply across and divide through on the bottom, we are going to be left with moles of sodium sulfide. Once we're in moles of sodium sulfide, we can go all the way across and calculate the moles of copper sulfide using the molar ratios in the equation. And as you can see here, this one's really easy. It's a 1-to-1 ratio. If there's no number in front, it means it's a 1. So, for every 1 mole of copper sulfide, we have 1 mole of sodium sulfide. And I have moles of sodium sulfide on the bottom because we need them to cancel with the moles of sodium sulfide up here at the top. So I'm going to go ahead and cancel my units out here so as we can just keep them in track. We have moles of sodium sulfide on the top, and those cancel with moles of sodium and sulfide on the bottom. Remember, things that are diagonal from each other cancel out. So now we're in moles of copper sulfide, but we're going to take this all the way to grams of copper sulfide. So we can do that using the molar mass of copper sulfide. We have 95.62 grams of copper sulfide for every 1 mole of copper sulfide. And again, the units cancel here. A mole of copper sulfide cancels with a mole of copper sulfide. And we are left, when we do all the math out here, I'm going to multiply on the top and divide on the bottom. We are left with 18.4 grams of copper sulfide. And this is going to come into play in a minute because we're going to now go through and calculate out the amount of copper sulfide we get with the given amount of copper sulfate. So, because remember we have to figure out the limiting reagent here. We start with 10.3 grams of copper sulfate. We're going to go through the exact same process here. We're going to convert. So in every 1 mole of copper sulfate, we have 159.62 grams of copper sulfate. Okay? So now the grams are going to cancel. With grams of copper sulfate cancel on the top and the bottom. So now we're in moles of copper sulfate, and we can convert to moles of copper sulfide. So we have 1 mole of copper sulfide for every 1 mole of copper sulfate. And the moles on the top and the bottom of copper sulfate cancel. And now we can convert to grams of copper sulfide, because for every 1 mole of copper sulfide, there are 95.62 grams in copper sulfide. And what this gives us is 6.2 grams. when we multiply, divide, multiply, and multiply. And this is 6.2 grams of copper sulfide. So now if we look at the difference between 18.4 grams of copper sulfide and 6.2 grams of copper sulfide, we look to see which one is smaller. And the 6.2 grams of copper sulfide is smaller than the 18.4 grams. So that means that our copper sulfate, the amount of copper sulfate that we were given, is the limiting reactant in this equation. Okay, so this is the amount of copper sulfate, or copper sulfide, that we are going to get with copper sulfate. Okay, the next step to this problem is to solve for the percent yield. I'm going to erase all this. So remember, we have 6.2 grams of copper sulfide. Okay, so that's how much copper sulfide we are going to have. Oops, CUS. Okay, this is what's called the theoretical yield. I'm going to call it the TY, theoretical yield. In a perfect world, given the amount of copper sulfate we were given, we can get 6.2 grams of copper sulfide. Now, we know that life is never perfect. So sometimes reactions are not 100%. You don't get 100% yield for all sorts of different reasons. So in this case, we were given that we actually got 4.9 grams of copper sulfide. This is what's called the actual yield. Okay, remember I said life is never perfect. We got less copper sulfide than we would have expected. So we can calculate the percent yield is equal to the actual yield over the total yield times 100%. So this is going to be equal to 4.9 grams over 6.2 grams times 100. And this gives us 79%. Okay? So this reaction was only 79% efficient. It only made 79% of what we would expect. So that's how you go through when you calculate percent yield, is you're kind of looking at how imperfect your reaction is. Because like I said, life is never perfect. We take this is what we would have expected, the total yield, and this is what or the theoretical yield, and this is what we actually got, which is the actual yield. So I hope this cleared up some confusion. Problems like this, I can guarantee you're going to see at least one of them on your midterm. So make sure you can take a problem like this all the way through, from start to finish, figuring out limiting reagent and percent yield. So thanks for watching, guys.